Hello, good afternoon, and welcome. Welcome to Scale's LinkedIn Live, broadcasting live on LinkedIn and YouTube. Today's topic is how to build agentic AI safely in regulated SaaS. And we're going to cover the 7 subsystems you need. My name is Alastair. I'm a co-founder and value partner governance at Scail. I have 2 decades experience bringing technology to bear on large corporates in order to maximize the human and technology value of tools like AI. And I'm delighted to say that today's expert guest is Douglas Cole. Welcome, Douglas. Hi.
Afternoon, Alastair.
Very nice to see you. Thanks for making the time to join me. So this is a practical engineering-led session for leaders who want agentic AI to create real value in their business without introducing unnecessary risk. And as I mentioned, Douglas is going to be our guide today. He's a value partner engineering at Scail. Douglas brings 2 decades of product engineering experience, including building and operationalizing AI-assisted development inside complex, highly available systems for organizations like the Bank of Ireland and the BBC. Douglas, it's absolutely fantastic to have you today. Maybe you'd like to just give us an overview of how you've helped big organizations reduce time on platform tasks and maintain code quality using AI.
So earlier on, or I suppose the best thing to say on this would be really helping gain access to things like Claude and gaining access to actually help the developers in there to gain access to things like harnesses that will help them do development. That's really where the rubber hits the road for the larger organizations at the moment.
Yeah, thank you. I mean, I put you under a bit of pressure there. I know that you helped increase platform tasks at a big bank by maintaining code quality across a large native React Native monorepo for over 100 developers. And excited to get into the seven subsystems today. Before we get started, please fire into LinkedIn if you've got any questions or comments live, and we'll try and incorporate those in the show. So Douglas and I are part of the Scail team that launched in April, and with a mission to build AI capability inside regulated SaaS businesses. You can read more about us at scalewithai.com. And over the last few years, we've worked with a number of leading regulated SaaS businesses and built complex technology systems inside a lot of these brands. And the truth is that AI is like powering development enormously, Douglas. Like one of the stats that we quote a lot is this 50+ features shipped by Spotify in 2025, which is phenomenal. I know you working with some of our fintech clients and inside our own business, you've seen like enormous gains in terms of quality in AI. Where are you seeing the most power?
At the moment, I think the most power is coming from the agentic development. So orchestrating a number of agents working across tasks in a coordinated fashion, which auditably doing things in the right way, testably, measurably, benchmarkable, that sort of thing.
Yeah. Okay. Thank you. One of the stats that you talk about regularly is, yeah, it's great that Spotify shipped these features, but a story just a few months ago from a startup where 9 seconds is all it took for API calls to delete a production database. So there's risk out there too, right?
Of course. I mean, the horror stories are everywhere, and it's a matter of control. And that is what you'll see a lot of today, is a lot of discussion around control. It keeps coming back to making sure that we're doing things in the right way. Yeah. I think it's good to go to a term now, which is deterministic. I try not to make things as technical or as untechnical as possible, but deterministic is quite a simple concept. Whatever we put into a system, what we get out is the same. Same inputs, same outputs. But as we all know with AI, same input, very different output. Yeah. And a lot of that control will be around trying to guide things in a more deterministic way.
Yeah. Fantastic. Thank you. So very excited to run through in the next 24 minutes these 7 subsystems that we believe are absolutely necessary for safe agentic SaaS, software as a service development. We're going to pick through each one of these 7 and Douglas is going to share our approach to that, why that exists, what the tech stack is in the middle of that. But the truth is, my friend, that some things never change, right? And that before you get into those 7, you know, the requirements gathering, the context definition is a deeply human thing and is required right now, even if that element is AI supported. And I think before we get into the deep technical 7 subsystems, it's important to say that contract, that requirements capturing, the creation of a contract which can be augmented by AI has to be led by humans, has to be overseen by humans, as does the collection of design assets and other essential things. You know, let's before you talked about definitions, right, and deterministic. I just wanted to flash up before we start on those 7 and talk about analogies just for people on the call. So we're going to be talking a lot about LLMs, large language models, that Andrej Karpathy says is that the kernel process, the absolute cornerstone really of this new AI operating system. Retrieval augmented generation, I think comes up once or twice, which is effectively the LLM plus the books, so the brain plus books. We're going to be talking about AI agents, where that LLM is supported by hands. They're taking actions. We're using memory and tools, and then finally, my friend, the MCP server, right, that connects everything, that ensures seamless integrations. And you know, MCP is something that you're going to be talking about a lot today. Very passionate about. Do you want to give us your definition of your high level kind of layman's terms of what an MCP server is?
The best I've read is it's like USB-C for your agent. It kind of is. It means you can take your agent, you can plug it into something, that agent can query it, understand what's available, understand how to do things, and gain knowledge about a system. So it's yeah, useful bits of kit.
Yeah, fantastic. So hopefully that analogy makes sense, and we can use that as we dive through these 7 subsystems. The first of which is the agent playbook. So the first of the 7 is our agent playbook. Douglas, what is the agent playbook?
So the agent playbook is a highly opinionated set of rules, patterns, guidelines. One of the other keys to the playbook is a subset, a language subset. So we're looking at agentically safe TypeScript, agentically safe Python. We want a subset of the language. You want to guide our testing agents, our coding agents, review, etc., to be doing things the way we want them to be done. Again, you knew I'd say it, deterministically. We can't be deterministic. It's not possible. But what we can do is we can drive things the right way. Inside the playbook, we have skills, rules, commands, very much like Claude code skills, much like things are used elsewhere by harnesses. In fact, we boil it down to something that's even sort of beneath the harness. So we can then give that to Claude code and it can create a skill. We can give it to an agent and it can also learn that skill or have that skill as well. So all those skills are stored centrally. We version those skills. We have metrics on those skills, etc. We benchmark them. We can then start to change them. That playbook also has input. This is very much a human-governed system. You don't want agents going to the playbook and changing things. This is how the very crux of how things are going to be made. But as agents are doing their work, they're going to come up with things that aren't quite right, and we need a mechanism for that to come back into the playbook, for the playbook to be then changed, raised to a human checks, makes a change, that change is then ecosystem-wide. And I will start talking about ecosystems presently.
Well, we'll get on to that. So, is that you talked about that human only element, and I think you've covered off, a lot of the rules and guidance that sit inside that playbook. And the reason, we've listed these out for ease of understanding and in an order, and we're going to run through that order. It's kind of quasi chronological, but obviously these different systems are interacting with each other at different levels. And so it makes sense that we'd start with the playbook, the rules, the guidelines. We move pretty swiftly onto the second subsystem.
Sorry,
go on.
Just before you move, I just wanted something I wanted to add in there, which is that the core piece of technology for the playbook is an MCP server. Our agents that are doing our work for us, they need to communicate in, so the playbook itself is an MCP server. Our agents talk to it, get the rules as part of a pre-flight operation, which I'll come to later. But I just wanted it to be clear that it really is, it's an MCP server for the agents.
Okay, fantastic. And that covers everything off in the agent playbook. There's nothing else you want to add, my friend?
Nope, all good.
No. Okay, great. So that's the agent playbook, setting the tone. We move on to the knowledge base. What is number 2, Douglas? What's the knowledge base in this instance?
So the knowledge base comes from a concept of an ecosystem of projects, an ecosystem of things that we're doing with our business. They could be the agent playbook itself. They could be a system that you're using. All of these 7 systems would live within your ecosystem. And then we have something that manages that ecosystem, almost a broker to that ecosystem. A piece of technology, we're calling it our knowledge base. Once again, it's an MCP server, so our agents can connect to it. It is based on a vector database searching. So we are using Amazon's OpenSearch, and that gives us the ability to put our code into there. So as the agents, for instance, are trying to find out, I want to write something with a Lambda that processes something in a certain way, we can go to our knowledge base, to all of our projects, and we can find the similar kind of things. How has it been done before? We get that together in the vector search, and that can be then added to the agent. Once again, we're into RAG. We've got retrieval augmented because we're generation. We know what we want to do. We can then go and get the relevant things from the knowledge base to what we're doing. What the knowledge base also has is a set of skills and rules that every one of the projects that sits in this ecosystem conforms to. I have a major change to an event. I want to tell the world about this. So we do. We raise an event up from every project in the ecosystem, and our knowledge base captures that and goes, great, this piece of code works, or this thing works differently. We've then got that information in a centralized place, which we can then share to other things like ChatGPT projects. Suddenly, we can then have our Claude code talking to ChatGPT on the context of our code, of our ecosystem, and then you can have some really powerful conversations, which is what we've done.
Fantastic. And as that knowledge base connects everything, it's recording all the actions, it's recording all the learnings. What kind of level of telemetry are we talking here in terms of what's being captured inside the knowledge base?
It's a good question. It's difficult. It's an ongoing thing. What level of information do we go to? Events, there are some really key things that are really important for other systems to understand. What level that is a tricky one. Have too much, and then you've just got a complete copy of your code base. It takes the LLMs a long time to process that. So it's really succinct. It's trying to boil things down, but not too far. And it's an art form. And if I said I knew the answer, I'd be lying. I'm playing it. One of the settings that we're tweaking and playing with all the time and benchmarking and seeing and trying to learn.
Yeah, I guess it really depends on the requirements of the product or the feature that you're building. Anything else on the knowledge base before we move on?
Not for now, but it'll probably crop up. It usually does.
Okay, great. So you got a bit of a sneak peek there. Number 3 on our list is the design core. So we've gone through that requirements capture and the context definitions of the human to create our contract, our words, and we've gathered our assets together with images. And those images we're going to need now that we've gone through the playbook and the knowledge base. We're into the design core, right? The third step. So what's the design core, Douglas? How would you define that as a subsystem, design core?
So it is a classic design system. Like Audi's design system has been knocking around for a few years. We have a component library, again, very opinionated on what a component looks like. What's the gap between it? What's the border? What color when it's highlighted? In detail information about exactly how individual components work, how they are built up as a set to create a form, how they interact with each other. This is all really important information and always has been required in order for us to make systems that are consistent for users, etc. People often don't follow those rules. And it's one of the things with the knowledge base. You tell developers what to do, they don't follow them. The LLMs almost always do. Well, almost, obviously, the hallucinations aside. But it certainly helps with that. So, yes, so the design core. So, as it was beforehand, we've still got a design system, works very much the same way. The major change is the agent connector. Good old MCP server again. We have our design agent. Design agent is coming to design this, and we want a consistent design. We want determinism. We want this to look the same. Doesn't matter how many times we plug this through. The design system gives us the ability to do that. And the MCP server gives the connection for the agent doing the design work access in there to get exactly what it needs. We now have consistent UIs, consistent ways of working. And another beauty of this is we have something like Storybook, giving designers, project owners, project managers the ability to play with this stuff real time. iOS, Android, web, always going to be the same. And people are going to actually play with the thing on a real device to see what it looks like. And that is really valuable. Agents are going to do what they're told. We end up with a more consistent output.
Yeah, it's fantastic. One of our co-founders, Jackie Fessett, there on the wide on the left. Jackie looks after all things creative and visual design for us, and so getting her experience and feeding her the kinds of assets that she deems necessary, not just brand guidelines, but project specific assets, and getting those into the design core has been like a learning for us as we build that capability. Is there anything I've left out? I mean, you've left out, you talked about the consistency, and I guess the consistency is key. We know that AI has the potential for sycophancy and to run off the rails. So it's all about, a lot of this stuff you're talking about is about consistency. Anything you haven't covered in the design core you'd like to?
No, that's good to me.
Okay, fantastic. So we'll move on now from the design core. Actually, did we cover off any kind of like inputs and outputs for design core there? I think they're probably covered.
They are. I mean, one of the classics is something like Figma, and whether you house Figma or some Figma-esque product is one thing, or whether you just take an output for Figma, but you do need something. There's another layer there to build that design system, and that's a whole other topic and discussion. You know, taking that Figma and then taking that and building components from it that can be used as a whole other thing. We're just assuming we've got a nice, lovely design system called the design core that's done all that for us.
Okay, well, let's move on from the design core. So the agent playbook's got all the rules. Our knowledge base is all of our different systems and subsystems connecting together. Design core is how everything is going to look and feel before we go and build it. And now we're starting to get into the kind of the core build phase, right? And the next one before we start building is the work manager. What's the work manager, Douglas? How would you define it?
It's quite a simple definition. It's Jira for agents. So most people know Jira, a ticket system, concept of a project. Inside a project, we have a set of epics, major journeys, maybe major bits of functionality. Within an epic, we have tickets, individual things, a story, a task, a bug, something that happens. And then that can be split down further into tasks, which actually heads up are our agent tasks, which is Jira, really. But it's just a subset of what we need for the agents to do the work. Much like Jira, we have descriptions, we have estimations, we put token estimations in there, and then actually what the tokens cost, and then we can do some analysis of how we're predicting that sort of thing. Yeah, so it's a structure, as you would expect in Jira, that gives the agents all the information they need. And one of the really key things with the work manager is it's goal orientated. Now, we have a goal for the whole project. I want to build a replacement piece of software for 0. Fantastic, that's a really high level goal. Right, we break that down, we then have an epic. That epic has a goal. Ticket, your ticket has a goal. Your task has a goal. So when our agent comes to take the task, it's not just the task it's interested in. It needs to look at the whole chain. And one of the tests that we've done, which in fact I'll come to that in the orchestra when I come to that to sort of go through that. But yes, so it's that all the information, which means if an agent gets blocked, can't do a piece of work, there's not enough evidence for it to say that that this task has worked, it will block that ticket, much like you will see in Jira, Trello now, and a human will then have to go and look at this and go and check it and give input, and then it can go back into the mix and it can go back in. So all of that ticket management, task handling, where are we up to, what's the token burn? As well as that MCP server, of course, you knew I was going to say that, as well as that MCP server that gives our agents the ability to connect and connect out, we have a web UI for humans. Why did we pick this structure? We could have picked any structure we like. Well, humans understand epics, humans understand projects, humans understand tickets, tasks. We've copied the same thing so that when a human looks at this, they can see the burn down, they can see the usage, they can see what's in the backlog, what are the bugs, what are the spikes. Give the interface the same look and feel so people understand it, and then underneath we start to change more and more things to be more agentic.
Fantastic. Let's move on from the work manager into what we're calling, or what we refer to as, the orchestra. What is the orchestra, Douglas?
So the orchestra is our pool of agents. These are the agents I keep banging on about. We are using Fargate in AWS. We've got hardened Docker images, and every task that needs to be done is a hardened Docker image spun up by the orchestra, which is our task scheduler. It can then go and do its job. The orchestra manages all of those things. It manages the pre-flight checks. So before a task is undertaken by an agent, is this task sensible? Does it have enough information? Is it even in the right format? Do we think it can do it? There are some really, it sounds really simple, but the agents will make these classic mistakes. So we have a bunch of, and this is really important, deterministic checks. Your pre-flight never talks to an agent. I don't want LLM communication at this point because it's too slow. I want to be using fast API. I want to be using Python. I want this to be as rapid as I can so that it gets out the way. And the determinism is absolutely vital. The next thing we've got in here is, it's not called a post-flight check, it could be. It is our behavior contract monitor. When an agent is finished with a task, this contract behavior monitor looks at it and looks at what's been done and checks it against all these goals, checks it against everything that's been done. Do I have enough evidence to support that this can now move to the next stage? And if that's a no, good old human gets involved. But every time the human gets involved, we are creating information through our knowledge base. We are asking questions to the playbook. Always, we're going back and forth. So any time there's a problem, we're feeding back into the ecosystem. The ecosystem understands it. We haven't quite got this in place yet, and we're planning that the ecosystem can find a problem, change request gets raised to another system, everything gets done, we just see a few PRs. Oh, we found this problem, PR, done. That's our blue sky, but that is what the orchestra and these other systems can start to put together.
Great. So let's skip on from the orchestra onto subsystem 6, pipeline builder. Should be self-explanatory. Add a little bit of detail for us, Douglas, about what the pipeline builder is doing after the orchestra has finished its work.
It's doing code quality checks. It is a classic pipeline, Jenkins-esque. We will be talking to SonarQube to make sure the code quality is high. Journey tests is something we haven't really discussed, but journey tests can fit in here nicely. OpenClaw and journey tests is slightly scary, but as long as OpenClaw is given its nice own little hardened Docker container, it can run wild and go and do some testing. The other thing that we haven't got in there that I like to mention is what I call Quincy. It's our QA agent, and it could well fit into the pipeline. This is your OpenClaw agent that is just going wild. It's trying to do funny things. It's actually proper QA. Like, can we make this better? Can we break it? Can we do something really funky? This isn't writing tests. This is another step that is, can we go left field? Or can we improve this? It's proper, trying to do proper QA. And that's something we haven't mentioned that would certainly be sitting in that pipeline. But yes, okay. Sonar Cube checks, deployment to Play stores, deployment to web server, deployment to AWS, deployment to everything like that. It's a good old classic pipeline, nice and simple and as unagentic as possible. Once again, this is deterministic where we can. And another little nugget I'll give you is all of these MCP servers that I talked to, we're talking to this MCP server to get this back. It always starts with a communication through an MCP server. And then you start to see that there are parts of this that are done every single time by an agent. MCP connections are expensive in tokens. You've got an LLM talking to another LLM. It's expensive. Sometimes, and often in fact, we can take a subset of that and we can move it into an HTTP API call, just a bog standard call across the internet. You're not now being charged tokens. So the MCP servers are fantastic and where they're necessary, but now you can start to move it across. So every single MCP server, and make sure we can do stuff manually without the LLMs being involved.
Thank you. And then let's move on to the last of the 7 subsystems. So the secret safe. Tell us about this. What's the secret safe subsystem that we use?
So this is a fairly thin layer on top of AWS's secret manager. We've got API tokens up the hundreds of them, and they need management. The naming of them is absolutely vital, and giving them subsystem names and being consistent is absolutely vital. Otherwise, it's just a nightmare. Keeping them cycled, that sort of thing is part of it as well. There's cycling. What's going on with these? I want real-time information. Say, hey, I've got a key that's going to die soon. That sort of thing. So it's managing that. The other really useful thing with the Vault is when you have a developer using Claude code or something like that, and we want to make sure that they're doing things in the right way. And there are lots of rules around the Vault that mean you cannot put API keys in your projects. You can't bake something in. It won't actually let you. And I have tried because we were doing a demo and I could not get Claude to do what I wanted. I had to go to my skill and go and say, well, if Douglas says this, then so yeah. So that's very much the rule of the Vault as well, is to govern, to make sure we don't get bad practices. We make sure we keep APIs safe and we keep API keys out of configs, out of local storage, keep them in memory for as short as possible, all those kind of good stuff. They're rules within the Vault. Sorry.
Thank you. I mean, that wraps it up with Secret Safe. I think some of the stuff you said just in the last 2 minutes, you've written an article on scripts. You're a big fan of scripts in order to keep token costs down. And there's 1 or 2 other things that you've mentioned are articles that people could read that you've written on this subject on our website at scalewithai.com. Hopefully these 7 subsystems have been articulated clearly by us, even though we're moving at extreme pace. If you're one of the ways that Scail can help you is through our diagnostic, our building, and our operationalizing capability. We have a brand new product called Pulse that takes a snapshot of company-wide AI readiness that we do every 100 days. We also, they're very short engagements. We also run 2-week capability bursts, and we put 7 of these together in order to deliver our 100-day transformation packages that evolve businesses, helping them build AI capability, specifically in the regulated SaaS area. That is a real strong suit for us, a real strong area, and one in which we have a lot of experience. And we always start these engagements, whether they're Pulse or Sprint or Evolve, we always start with our AI risk and value scorecard, whether that's human-led or automated. If you want to hear more about us or get in touch with us about anything that you've heard today, you can go to the website scalewithai.com. You can also reach out to Douglas or I on LinkedIn. My friend, colleague, thank you so much for your time today, Douglas. That was fantastic. You know, it's a whistle-stop tour through those 7 subsystems, but I really appreciate you putting the time and effort in to articulate those and share how Scail is approaching its agentic development and some of the processes that we're using with some of our clients, one of which is a fintech business. So thank you for sharing so openly.
My pleasure.
Any final words, my friend, before we wrap up? Anything that's been on your mind recently that you've seen in the news, or anything that you've left off the 7 that you'd like to add before we wrap up?
Not really. The one thing that I would end with is that my experience, my observation, shall we say, is that every time you make an MCP server, an LLM does something of interest. Might be good, might be bad, but every time I've built one, something funky happens.
Okay. Well, great. I shall keep my eyes open for funky stuff with the MCP servers in the news in order to share that. Thank you, everybody, for watching, listening, tuning in. Thank you very much, Douglas. I'll see you all next time. Bye for now.